This is question number 19 of summer 2015 additional math IGCSE, and paper is 13. Question number 9. The diagram shows parts of a line 3x plus 10 and the curve x cubed minus 5 squared plus 3x plus 10. The line and the curve both pass through point A here. On the y-axis, the curve has a maximum at B here and a minimum at C. Okay, and these are the lines parallel to y-axis. They are intersecting the line at D and the curve at C. All right, so we have to, in first part of the question, we have to show that the line AD is a tangent to the curve A. How can we show that? The line's equation is y equal to 3x plus 10, right? That means 10 is the y-intercept, which means that the y coordinate of point A is 10, and we already know that x coordinate is 0. So 0, 10 are the coordinates of A. And 3 is the gradient of D. That means if we differentiate the curve, this one, the dy over dx will be equal to 3 at the point A, where x is 0. So let's show that. So first we have to find dy over dx. We will differentiate this equation of the curve. It will be 3x squared minus 10x plus 3. And now if we substitute x equal to 0, because we know that at point A, x is 0, we should get dy over dx equal to 3, and we'll show that it is a tangent. So 3 times 0 square minus 10 times 0 plus 3. So this is 0, this is 0. Yes, we got 3. So we can say here that since dy over dx is equal to the gradient of line, the line is a tangent to the curve. That's it. Okay, let's see the next part. What is it about? It says find the coordinates of the point B and C. So they have already written that B is a maximum and C is a minimum. That means they're asking us the coordinates of the stationary points. And for stationary points, B and C, dy over dx has to be equal to 0. The gradient of the tangent will be 0. And let's equate. This was a dy over dx. So 3x squared minus 10x plus 3 is equal to 0. And this is a quadratic equation. It will give us 2x values, and they will be the x coordinates of each point. So let me factor this so that we get the values of x. So 3x squared will be 3x, x minus 3 minus 1. So one of them is 3x minus 1. The other one is x minus 3 equal to 0. And they become, this one will give us 3x minus 1 equal to 0. So x is 1 over 3. This gives us x minus 3 equal to 0, x equal to 3. Obviously, 1 over 3 is the x coordinate of the first point, which is on the left side lower point, which is B, and 3 is the x coordinate of C. Now, the original equation was x cubed minus 5x squared plus 3x. Let me write that one here. X cubed minus 5x squared plus 3x plus 10. This was the equation of the original curve, and we will substitute the values of X coordinates we just found out. To find the Y coordinate, because they're asking the full coordinates. So y equal to, let me substitute 1 first, 1 over 3 first. So 1 over 3 cube minus 1 over 3 square plus 3, 1 over 3 plus 10. So it becomes 1 over 27 minus 5 over 9. Okay, and 3 and 3 cancel, plus 1 plus 10. And if we add all of them, this 27 will be the LCM. So it will be 1 minus 15 plus 11 and 11 times 297. Okay, so it becomes how much? 282 and 281 over 298 minus 283. 283 over 27. This is the y coordinate of B. What about C? For that, again, I will substitute x equal to 3. So 3 cube minus 5, 3 square plus 3 times 3 plus 10. So it is 27 minus 45 plus 9 plus 10. So 27 plus 19 is 46, minus 45 is just 1, positive 1. And that makes sense, yeah? Thus, this coordinate of C becomes 3, 1. And this coordinate of B was 1 over 3, 283 over 27. Let's move on to the next part. It says find the area of the shaded region ABCD. Okay, so shaded region is the area between the curve and the line. So what can we do? We can find, first of all, the coordinates, 4 corners of this trapezium, so that we have the bigger picture. So these coordinates are 0, 0. This is 0, 10. We already know this. Here we know 3, 1. And we know the x coordinate of this D will be 3 because the vertical line, so x coordinate will be same as the point C. And let's put that 3 here. So it becomes 3 times 3, 9, 9 plus 10, 19, 390. Okay, so we can find the area of the trapezium now. Area of trapezium. What is the plan? Let me tell you the plan first. I will find the area of the whole trapezium, this one. Then I will find the area, this white area under the curve by integration. And I will subtract from trapezium, we will be left with the shaded part. That is the plan. So I'm first finding the area of the trapezium. So area of trapezium is half first parallel line, which is this, and this is the y value 10, plus second parallel line, which is this, which is 19. Yeah, 19. Okay, 19. And multiplied by the height, the distance between the two, which is 3. Yeah, it is 0, this is 3. So x distance between them is 3. So it becomes 29 times 3, 87 divided by 2, 43.5 units squared. This is the area of the trapezium. Now, the challenge is to find the area under the curve from x equal to 0 to x equal to 3. And that we will subtract from the trapezium's area. So let's do it here. The equation of the curve was x cubed minus 5x squared plus 3x plus 10 dx from 0 to 3. So it becomes x to the power 4 over 4 minus 5x cubed over 3 plus 3x squared over 2 plus 10x plus c from 0 to 3. Let me substitute the values of 3 and 0. Ten times 3 plus c minus This will be 0. First one, if I substitute 0 here, then next one will be 0, next one will be 0, every one will be 0, and plus C, and C will also get cancelled out. So this is the only one area left. So the area is 81 over 4 minus 135 over 3, and that will be 27 over 2 plus 30. Actually, this is positive. And I got 18.75 here, and earlier the area of the trapezium was 43.5 minus 18.75. It will be 24.75 units square.